Okay, let's have a look at question 6. Now question 6, we gave you a few trigonometry graphs, and before you even start, let us bring up the mental images again. For f of x, you know that cosine, you know from previous years of trigonometry, cosine starts at 1, goes through 90, minimizes at 180, goes through 270, and then reaches a maximum again at 360. Now what does this half represent? This half changes the y values, not the x values. So instead of going from 1 to minus 1, it has an amplitude of a half and minus a half. If we look at the tan of 6x, now I'm only going to look at tan over the first 180 degrees. Tan goes to its asymptote at 90, and your mental image then tells you it goes from 180 again towards the asymptote. The important point here is the point 45 and 1. Now look at where the change happened. The change happened with the x. So the y values are unchanged. Okay, so what does it mean? There's a shrinking. So this graph is going to be compressed by a factor of 6x. So every x value is going to happen where the asymptote was at 90. It's at 90 divided by 6. Where the 0 was at 180, it's divided by 6, so it will happen at 30. So remember, your period for tan is 180, so this influences the period. If I go and look at h of x over here, the cosine x graph again will have that shape going from minus 1 to 1. You should know this. This should be the mental image in your head. Okay, this is not, you can't find any of this on a formula sheet. Please, folks, get to know your mathematics, and I promise you, if you know what these things look like intuitively, you will know how to change them. This is a vertical translation. Again, it's not connected to the x because there's no bracket there. And if it was connected to the x, it should have been in a bracket like the third part with a degree. So this is a vertical translation 2 units down. Okay, so this would mean 1 minus 2, which will be minus 1. Minus 1 minus 2 lies at minus 3. So the range of that graph is from minus 3 to 1. The period is changed here, and here the range again is from minus a half to a half. The third one is an interesting one. It's your sine graph, which you have a mental image of. It does that, 0, 180, 360. And I'm minusing 30, which means if I minus in the equation, every x point is going to move 30 degrees to the right. Every important point here translates 30 degrees to the right, so the graph will more or less lie over here. The range is unchanged. The period is also unchanged because it wasn't connected to the x directly like the 6x was. Here I am only translating the graph. I'm not stretching or shrinking it like I'm doing in option number 2. Okay, let's see what are the questions that they ask us. First of all, in 6.1a, they said find the range of f. Now the range of f, we already have the image, so the y values there lies between a half and minus a half. Or you could say y is an element square bracket, minus a half, square bracket, a half. Okay, both inclusive because the end points do lie on the curve. The next one they ask us for, so this was for the range of f. That's what we were looking at. Okay, so the y values on f lies between those two limits. Now they ask us for the period of g. Okay, now g is this weird graph, the 6x graph. Now the normal period for this function, the period for the mother curve of tan, is 180 degrees, but that would have been if it was the tan of x. Now we have the tan of 6x, so we have to change the 180 degree period now does not relate to x but to 6x. So x will give you, if you divide both sides by 3, it will give you 30 degrees. So the period of the function g will be 30 degrees. That was a full 1 mark. Okay, 6.2. We asked you, where will, now this is lovely, I love this, where is h of x, where will h of x have a minimum value? Okay, now remember h of x is your third curve over here, and the transformation changes every point. What does it do to every point? It changes its y coordinate because it's a vertical translation. So the minimum here, and you know your minimum happens at 180. Let me put the coordinate pair down here. 180 and minus 1. So the minimum for the new function, the transformed function, the minimum value will be 180 degrees and minus 1 minus a translation further downwards of 2 units in the y direction. So the minimum value happens at 180 and minus 3. Okay, let's see. And they told us, sorry, they also said we're only interested on the interval 0 to 360. So they made it easy on us. We didn't have to go and put down a general solution here. Okay, then the second part, which is part B, the second question asks us 1 plus k of x. Where will this have a maximum value? So these two were the questions, and it's also over the same domain. Now if I go to k of x, 1 plus k of x is what? It is 1 plus the sine of x minus 30 degrees. Okay, so if we just look at where the maximum value of this function on the given domain will happen at this point for the mother curve, the sine of x, it would have happened at 90 and 1. Okay, but what happened? We moved it 30 degrees to the right. So at this point in time, it will be at 120 degrees. The 90 plus 30 to accommodate the horizontal shift 30 degrees to the right. Okay, at that point, the maximum value was still 1. But now we're translating it 1 upwards. So it's 1 plus 1, which will then give us 120 degrees and 2 for the maximum value on the interval 0 to 360. Folks, it's not difficult. It is very, very easy if you know the mental images of the mother functions. So y equals cos x, y equals sin x, y equals tan x. Know where the maximums are, know where the minimum points are, know where the turning points are on the interval 0 to 360. Then it's easy for you to interpret the same graph with a particular transformation we've applied to it.